Hi everyone, thanks for joining me for this session of the Tech Forum 2021. I'm Alistair McCrudden, been a 12D model tech support and training for many years, along with a fair group of us. I've got 40 years industry experience as a civil designer, and I've been with 12D for over 25 years. So what are we getting into today? The rail fundamentals, which is going to follow on from a talk that I gave at the last Tech Forum, which was demystifying track terminology. That was purely running through the wording of what goes on to give you a little bit of a flavor of what happens. So today we're going to have a look at the primary tools in the track toolbar, what's in the toolbox. It's going to be a very quick look at what's in there. For the more experienced users, there'll be a couple of nice little things to learn along the way, some tweaks that have been done which will hopefully make it look really good for you and work well for you. But primarily it is based for the people who are just starting to get into track. But for the good users, hang in there, and hopefully we've got a few little tools there that you'll like the look of. Okay, so what we've got going to cover in the session, first of all, there's the calc centerline. So with the calc centerline, what we do there is we've got the surveyed track, so they'll have gone along and given us shots on the left hand rail and the right hand rail. We then will load those in, run the calc centerline tool on those two rails, and it will then go and give us a straight line segments through the points that have been surveyed. We would then run a regression or best fit of lines and arcs through there, and from that we would actually then build up our alignment strings. We then have the turnouts. So with the turnouts we would create those turnouts. We could read existing turnouts if they've been written away. We can write existing turnouts, and of course we can place the turnouts. So we'll be looking at turnouts. Turnouts are really, as I like to call them, intersections for rail design. One that we won't actually physically do is to look at the copy VG. What that'll allow you to do is, once you've gone and if you've put in a duplicate alignment, it might be just a short portion of duplicate for a passing lane, or it could be a totally new alignment that you're designing and putting in next to an existing one, and you wanted to copy the vertical geometry from that. That'll then go across. It's very similar to just using the standard super alignment copy vertical geometry, with a slight difference. Next one we have then is a slew diagram. So once we've gone and put in our passing lane or whatever it is, as we're diverging away from or merging back in at the end of it, we would want to create what's called a slew diagram. So that slew diagram shows us the amount of shift that there's been, both horizontally and or vertically, from the existing track to your new track. So that's what the slew diagram is all about. From there we'll go along and calculate cant. So cant is basically super elevation for rail, and the way it works is that when you're going along on a normal track, both the heads of both the rails would be at exactly the same height on a straight, and as you're going in then into a left hand turn, what would happen is the right rail would start to lift. That's basically your transitions. It would then stay at the raised height, whatever it happens to be, through the curve, and then it'll transition back down again until they're both level. Of course, if you're going to the right hand side, then the opposite would happen, where your left track would start to come up through the transition. You would then keep that track high through the curve, back down at the end of the transition, and away you go, level again. So that's what our cant is all about. Once we've done that cant, we can then plot the rails. So what happens here is that we are actually producing super strings which are 3D elements, which have got the position of the rails themselves, the individual left and right rail, with the cant applied, so we can actually then go and plot all of those rails and see exactly the heights are. So again, as I said, sort of a little bit like super elevation, if you'd like to call it that. We have an option in there to label alignment. So this is slightly different from the normal super alignment labeling that we have in there, because what this does is this labels the amount of cant that happens on each of the transitions and the curves and so on. So it's a slight variation. Again, you can make up, similar to our super alignment label types. You can make up your own ones to suit your own particular needs. Once we've done that, we will then make a structure gauge. So that's where one of the nice little things for the experienced users is going to come in. So the structure gauge, basically what we do is we take the, if you like, the envelope of the vehicle, whatever it is, whether it's a passenger wagon or a goods wagon, open top, whatever it might be, and we would then give that an offset, a safety factor, an offset for that envelope, and then create this structure gauge. That then would be checked against things such as your power pylons, your gantries, or indeed tunnels if you're going into tunnels, that sort of thing. So that would then, where you go and check all of that, doing your clash detection, making sure that you're not going to wipe out the front or the back of the train as you go through some form of structure. And then the last thing, which again I'll just talk about but not actually show you, is that we've got some chainage equality inquiries in there. So when we do chainage equalities, they can be fairly complex, and so I'm not going to cover that in any great detail. Indeed, any of the stuff that's in this talk has already been produced as fairly in-depth training videos on our YouTube channel, so certainly go in and have a look there. Chainage equalities are where we do weird things like redefining chainages at certain points along the design, particularly if you've gone and done a slew and or amended the alignment and they want to keep chainage signage the same as it was. Well, what that then means is that you've got two different chainages along that line. We've got what we call a raw or the real chainage, and then we've got a labeled or fictitious chainage distance along that string. So enough yakking with that. This isn't a session for PowerPoint only. So what we're going to do is we're going to go through and straight into a project. Okay, so what I've got here in my project is, first of all, the track tools, which I'll pull down there. Those can also be accessed through the design, track, and there are the track tools there. So I'll put those there for a moment, but I'll probably put them out of the way once we get going. So these are pretty much the same options that we have in the track menu. With the turnouts in there, we've got place, create, read, edit. The same thing happens up here, where we've got read, write, create, and place. The other ones that have got a few pullouts in here are for the plotting of the rails, plotting the profiles, and structure gauge. So we've got most of those sitting up there, and then a chainage equality and so on in there. Okay, so I'll just pull that one out of the way for the moment, and we'll get straight into it. So the first option that we have in here is to create our centerline. Now I've run most of this sort of stuff already as functions in the background, so it's the old thing of here's one I produced earlier. It's been sitting in the fridge chilling until I needed to use it. But basically what we've got here is our, I'll just put the dynamic inquiry on there, so you can see that as I hover over that string there's my railway line left and my railway line right. So I say line, that's the left rail and the right rail showing in there. So what we're going to do here is we're going to come in and say, right, I want to go and select the left rail. Now these two rails do need to be going in the same direction. That's one thing that is critical for you to do. Then I'm going to go and choose the right hand rail. We then have a whole series of things as to, sort of track centerline models, digital terrain models, cutting the rail left, cutting the rail right, and a search distance for this. So that would obviously depend upon your gauge that you want through there. So without further ado, I'll just go and process that. We'll then come across to have a look here at what we've done. So I've already switched on some models in this view. So we now have the left rail sitting over here and the right rail sitting there. We've got this new string that's been designed down the level, down the center here. As I said, it's straight line segments. So that's because those are the points that are being picked up. And then what we've done is we've cut cross sections through those points. So you can see that if the point hasn't been selected opposite the other rail, well then our cross section actually cuts at a bit of a weird angle. That's a bit of an extreme one which I've left in there to show you. But you can see that down here there's a slight variation. So they're not perpendicular. They can't be, because there's no telling whether the surveyor has actually picked up those points perpendicular or not. But what it has done is, in all cases, regardless of what the angle is, it's gone and found the center point between the two rails, and it's drawn us that center line through there. So that's basically giving us the first session of the set. What we would then do once we have developed that is we'd actually go in and put in some regression strings. Now, I'm not going to cover anything on regression in this particular session because there is a separate session which will show the new regression tools that are in version 15. So I don't want to let anything out the bag. Go and watch that as a separate session. I think you'll hopefully be really amazed by what's going on in there. So that's one of the things for the experienced 12D users in the track tools. So what we would have to do here then is we'd go through and we put regression in, or best fit strings. And what we'd do is we'd split them up into the straights, into the arcs, and straights again. So this one actually has two arcs in here. It's got a compound curve in there, which I'll show you in a moment. We would then go and develop our super alignment string, generally as element design, or parts if you prefer to call it that, element design, because that will then enable us to select the existing geometry that we've built with these best fit strings and create the alignment. So onwards then we'll go into the alignment. I can just close that little beast down there, and you can see now that what I've done is I've gone and done my regression, and I've placed the design over my regressed elements. So I've got a regression string at the beginning here for the straight. I've got a regression string in the center here, which is showing up orange behind the green. That is a regression string, and then I've got the cyan string running off here giving me my straight. So I've gone and built up that alignment using the elements, separate session to see that. And you can see in here that I've got a compound curve, in that in this point here I've got a radius of 299, and over here I've got a radius of 398, say 399. So that basically has gone and given me my alignment. So I've just done a very short portion in here just for this very quick session for the tech forum. The next thing we may want to do then is to go and create from our main toolbar here. We may want to go and create a rail. So what we would do into there is to go and get the profile, rail profile, create edit, and I've already done one of these just to save some time. So what I've got is in here my rail profile. So I've read that in from a PDF. I've gone through, again the notes will cover all of this for you. I've gone through and produced that rail profile. That then will be used twice in most of your sessions, because what you'll be doing is when you go and create your turnouts, you will actually tell it what rail size, weight, profile you're using for your turnouts, which of course has to match what the main line is. And you'll also use it at the end when you're going in and plotting your rails. When we go and do that, we can do not only the 3D strings of those rails, which give us the cant, etc., but we can also then extrude those rails along the way there. So that was the plotted rail that I've got into there. So we'll now go on to our turnouts. Now the first thing is that with the turnouts you will normally get a plot, plan, AutoCAD MicroStation drawing which shows what the particular turnout set is going to look like. The reason I say that is that each developer of or manufacturer of the turnouts have their own different ways of doing it, and it may well be that when you start off a job, if it's a brand new greenfield site you have no idea who's going to be developing the turnouts, so you might just go and put in the actual geometry for the turnouts as center lines with a 1 in whatever it happens to be for your 1 in 12, 1 in 16, 1 in whatever it might be. But anyway, I've got a set here showing some of the information on the turnouts, and you can see in here this is the geometry for the crossing angle. This is I believe a 1 in 16 from memory. It gives me the angles that it's going to be crossing at, and it gives the radii, the geometry, etc. And then up the top here there's a few interesting things to have a look at for those that aren't involved in rail a lot. So what we have up here is we've got this first portion up here where the set line is coming in to here. We then have the turnouts coming through, and that is dropped into place as an element. The first sleepers at the beginning of the turnout here are individual normal sleepers. We then have a couple of long ones in here which would actually have the switching gear attached to them, so they'd have the motors that drive and shift the rails backwards and forwards to actually produce the turnout where the train is either going to go straight through on the main line or it's going to hit the internal rail, and that will then push it across to go through onto the outgoing excuse me, outgoing alignment. The other thing of interest in here is that we've got a couple of things in here where we've got a practical point of intersection, which would be this point just showing in here, and a theoretical point of intersection which is there. So because the rail itself doesn't live there, the theoretical point is where the two internal rails would theoretically touch one another, and the practical point is where the turnout is actually physically hitting there as a rail and sending the train one way or the other. Further along to the end here then we come through, and you'll notice that all the way through where we've got both sets of rails, the straight through and the turnout, these sleepers are slowly skewing across, giving you the half angle of the difference between the two alignments. And then we get to what's known as the last long sleeper, which is this sleeper here. That is the last sleeper that bears both of the sets of rails and holds them in place, both horizontally and vertically, to take the load. After that last long sleeper, you'll see that the sleepers here individually come back to being perpendicular to whichever of those tracks they happen to be related to. Right, so onto the turnouts themselves. So as I said to you before, we've got a few different icons in here. We can read in existing turnouts if they've already been produced, and so they can sit in a library and we don't have to reinvent them. We can write out some that we've just made now. Those can go to the library. We can create and edit the turnout, which we're going to look at, and we can then go and place one once we've done it. So let's load the turnout in here. This particular one is for a swing nose crossing, and you can see in here on the turnout details it's basically got the general geometry of what is going to happen with a basic turnout. We then have the switch design, which all of the dimensions and things that we're looking at here are in fact in the icon, the imagery behind what I'm showing here. We have the crossing design that gives us the one in whatever it happens to be. It gives us the crossing angle. You can go by the angle or as a turnout crossing number. So you could set the angle itself, or you can say it's going to be a 1 in 16, whichever you prefer to use. On the closure design, again, from the drawing itself here, we would go and get the gauge, the radius of the curves, the leading length coming in here, the extra toe length sitting here, the extra heel length, which is at the back here, and then down here, as I said, once you've gone and done the profile of your rail, you can then go in and put that in as the preferred option in there. You could go in and put in the sleeper details. Now on some jobs you're going to have to do that. Others, if it's basically in the development stage where you're creating greenfield work, you won't have to worry about that at all. You can then also output that as a 12DA file. So once we're happy with all of that, we would then go and write that out. So we're now going to go and look at placing some of these. So there's a couple of things here. I'm going to go and bring up a long section of my little bit of rail here and a plan view over here. When we go in to place the turnouts, so I've already gone and made some turnouts just to save time, as we said before. They've been marinated properly so that they'll be the correct flavor and so on. So with the turnout details, we would actually then go and give this a turnout function name. The beauty of having the function, of course, is that once we've set all of the details on this, if we were to go and change horizontally or vertically the alignment string that it's been placed on, because it's a function, when we recalc the function, that will then of course automatically replace the turnout with the correct horizontal and vertical alignment on it. So this, we call this a turnout 1, which is a 1 in 16. It's going to be using a narrow gauge 1 in 16 swing nose. I'm placing this by the toe of switch. So there's a whole series of different modes that you can place them. The front end, which would be the very front of the turnout set. The toe of switch, which is quite a common one. The theoretical point of crossing for the main or the loop, the K, which is the true crossing for the main line or the loop line, and then the back point of the main line or the loop line. In reality, a lot of those are very much the same thing. It's just whether you are trying to denote that they are critical to the crossing or the main line. We would then say that we want to go and place one turnout on the right hand side or the left, that it's going to have a centerlines model, the colors, etc., etc. Onto the reference geometry here. So what we're going to do here is we're going to go and place one. Again, we've got all the options in there, so we can go and put them at a vertex, which is quite a common one, at a chain edge, a drop point, whatever we decide. I'm using a chain edge. This is going normal, so it's going in the forward direction along the string, and I'm going to place that just around about before the end of this straight here. Now it's critical to understand that when you're placing turnouts, as per my speech at the last tech conference, there's two things you need to take into account. Horizontally, you would try, unless you've got a special turnout which would be a similar flexure, which is to go on a curve in the same direction as the curve, or a contraflexure, which is again on a curve but going the opposite direction of the curve. Those are very much more complex and expensive types of turnouts than standard turnouts which go on straights. Turnouts are a very expensive item. They're where you'll really chew up money in your design, so you really want to make a couple of things as cheap as possible. Firstly, if you can put the turnout on a straight, so over here horizontally we would want to probably go in and put it somewhere in there. The other thing you don't want to do is you don't want to put it on a vertical curve, because again these things have got moving parts in them, and if you've got a curve in your turnout geometry, first of all it's going to be very much more expensive. Secondly, it's going to wear a lot more. So although that's a great looking grade to put it in down there vertically, horizontally it's not a good idea because it's in a curve. Whereas once we come out over here, we're on a straight horizontally and on a set grade vertically. So that seems to be an ideal place to put that. So I will go, and over here we can go and plot the rail, so I can plot the rail there, and that's just going to go into its own model. And I don't have a height offset because I've done the design correctly. I won't bother plotting the sleepers, and so we'll just go back in here and we'll place the turnout. Now if we have a look over here, now you can see that I've got my turnout coming into there, so it's placed on that through alignment there. One of the nice little things that's happened in version 15 that used to happen, and we lost it for a version or two, is that we lost the ability to put in the geometry for the turnout. The center line, the super alignment string, went walkabout, and so we've got that back in again, fortunately, which is really good to have. Okay, so that's my first turnout. So then what I might well have is the other end of a turnout. Now I'm going to have a very short passing lane here. We wouldn't normally do this, but just to show you what happens here. So this one here, remember, I sent this one through in the normal direction, so that was going forward, and I placed it on the right hand side of the string, so it's turning out to the right. So if I then go and have a look at our second one, which is turnout number 2, what happens here is this is going to be placed on the left of the string, and the placement is going to be reversed. So in other words, I want this to go in the opposite direction. So if I go and place it, you'll actually see what I'm getting at there. So I'll place that one, and then there we are. So we can see here, if I just go and pull this view out now, and I'll get rid of that panel there. Over here, the first turnout came to the right. It was going in a forward direction, and then its twin at the other end, to put it back onto the main line if that's what you wanted to do, has been placed on the right hand side of the string, because it's actually being in the reverse direction. So one to the right, one to the left, reverse direction, normal direction, give us the changes between those two. Right. So the next thing that I wanted to take you to now was the slew diagram. So what we were talking about earlier with the slew is that when you go through, and we've got a couple of things happening in here, we've now got our surveyed strings that we've developed the centerline off using that first tool, the centerline calculation, and then we've gone and put in our new geometry line through the way here. So I'm now going to go and copy use the slew diagram. So what I'm going to do is, again, I do have a function in here, so I'll just go and choose that one. And what I need to do is say, I want this to be my surveyed center line. So that would normally be, as I said, it could be a true geometry string. In this case here it wasn't. It happened to be a series of straights that have gone in there. I've already chosen my new alignment string running through there. When I go and pick the strings, it automatically gives me the chainages and the start and end vertices. I can then go and put my slew diagram in and show exactly what's going on. So this then shows me how far to the left or the right of 0 I am, which is then telling me whether I've gone to the left or the right of the alignment string itself. And then I've got the horizontal curve in here. So then we can go and plot the strings. So I generally tend to plot the horizontals in there. As far as it going to the plotting the profiles and the track lift, I personally prefer to use a long section plot on that. I just like the way it comes out looking rather than the way it does through here. But again, it's all personal preferences, and we can also export that to a CSV file if we so wish. So without further ado, I'll just go and calc the slew, and what this has done for me, I'll just get that panel out the way. You can see what's happened here is, as if we look out from here, any time that I've got the text on the left hand side with 2 arrows going across here, it's saying, right, I have shoved the alignment in the direction of the arrows by the amount shown here. So back up the way here, we'll find that we've got a very small slew of 11 millimeters. Over here we've gone out to 112 millimeters. So this means that as the tamping machine went through, it would have to lift and change those alignments to suit. And then down here you can see that suddenly the text has gone to the other side of the screen of the alignment, and that's showing me that I've now shoved it to the left of the surveyed developed string, if you like. That's what my slew diagram looks like, and that of course can be written out to a report. It can be written out to an Excel spreadsheet, etc., as I showed you on the end of that last panel. So the next thing then is to go through and plot the cant. Now I did mention in the lead up to this, that the cant is really where we develop our super elevation for these strings. So by coming through here and going and picking on my design string, it picks up the development of the start and end of each of the elements, whether they are transitions, straights, curves, etc., and puts them into there for me. I then have design limits, so I can go and say, well, this would probably never be for a speed of 115 kilometers per hour. It would probably be something like, I don't know, 60 or something like that. And obviously we would change all of these things. We might have a maximum allowable radius of 400, 500, sorry, a minimum allowable radius of 400, 500, whatever it might be, 300, etc. And then we put in the amount of cant that we will or won't allow, what our deficiencies, our rate of change is allowed to be, all that sort of thing. Onto the cant graph, this then shows us exactly what's happening as a little graph down here. And if we've got any errors, then they will come up and they will be highlighted in red here for us, and we can move around, position our cursor over those, and it comes up and tells us what has gone wrong inside there. I'm not going to try and amend this or fix it in any way at the moment. It's purely showing what tools are in there. Onto our outputs, and again that can go in as a report file, as a text file. It can go through as a CSV, and you can open that in Excel, whatever it might be. So once we've produced the cant, we would then on the outputs go and say we're going to go and plot the strings. So we can go and apply that. And now we then come across to the long section for the plot of the cant. What I've got in here is this was one that I said I prefer to do the long section plot. So you can see down the bottom here I have got a cant diagram which shows, if I zoom in on that a little bit, I can either label it as no cant, that's the right rail at 4%, whatever it might be, and then the left rail and the right rail at 0 as opposed to no cant. So that's entirely up to you. And you can see up here that I have got the top of rail levels for the left and the right rail, and you can see there's a shift in those as we've gone through and produced and applied that cant. So that's calculated all of our cant for us. The next thing that we might then do is come through here and plot our rails. So the plotting of the rails will give us these 3D super alignment strings, and can also use an extrusion along those to give us the details. So again, I've got an existing function and I've filled in all the details that I want. I'm going to go and use my UIC60 rail type again for the extrusions. I won't bother plotting any ballast or any sleepers, sleeper setouts, or tunnel bore. So again, you can see those all in the training set of videos that have been produced already. So back in here, if I'm happy with all of that lot, I've got my rails going to be produced from start chainage to end chainage, etc. Calc the function, and now I have got my rails showing in place. So a couple of things. First of all, if I go to a cross section here, you can see that there is my center line string. I've then got a left rail over here. Because we've got a turn to the left, it means my right rail has been lifted. That is the rail develop point, and you can see the little shape of my rail profile in there. We can also come across here and see those now in our perspective view. So I've actually got my rails sitting in there, and they are extruded rails running along the way there. Okay, so one of the ones that isn't on this toolbar is the labeling. We've got two things in there. We've got a label alignment defaults. So that brings up a panel where we can go and set all of our different types of elements, chainage labels, horizontal and vertical, etc., etc. All the segments, whether they're going to be what we're going to put for the straights, what we're going to put for the transitions, what we're going to put for the curves, and tangents, etc. And we can output some tables. So I've just written this lot out as a default. I haven't done anything fancy with it at all. I've purely used a default. Then over here I can go and label the alignments. So that panel just comes up and looks like that. And we can go and give it a function name. And again, I've already done a label with default style, etc. So I won't bother going through that, but I will bring you into here and show you this is what that labeling looks like. So if I zoom in a little bit over here, you can see that we've got element number 2 here. It's got a straight length, which is taken directly off here. It's got a length and a bearing, etc. Then we come into here. This is for the transition. So we've got element number 3, transition length, which again matches what we've got into there. Transition cant grade, etc. The transition type. So it's a Westrail cubic I've used here. We have got the rate of cant in there and the deficiencies. And it's done that for each of these elements all the way along here. So it's a nice little extra tool to have rather than just the straightforward one that we use normally for labeling up the geometry itself. Okay, so we're on the home leg here now. So we're going to go through into the structure gauge. So as I said, what the structure gauge is used for is so we can build an envelope and then we can give that a safety factor, so we'll offset the actual carriage itself by X amount, whatever we decided we need to have as a safety factor. We can run this along the railway line. That takes into account all of your cant, so the vehicle will actually tilt. One of the big things we need to mention here is that this does not take into account any of the dynamics. So it doesn't take into account any of your movement through suspension, which of course will tend to make the vehicle sway. It also doesn't take into account any linkage movement that happens as you're going around a corner, which will then throw the nose and tail of the vehicles further out. So if you want to do that sort of very, very complex analysis, there are special tools out there which cost megabucks. Ours is really just so that we can give a first pass along there to see that we're happy that we're not going to hit any of our structures such as masts, tunnels, or gantries, things like that. So one of the beautiful things about this new version in here, it's had a little bit of love and given to it, and what it will do for us is when we go through, we read out all the information and so on, what it'll actually do for us is it will produce a tri-mesh. So I'm going to just come up here. I've already run this anyway. It's very, very quick. It takes no time at all to run the structure gauge, but I'll just go and add all my structure gauge models on in here. And again, that's all covered in our training notes. So what we have sitting in here now, this is a tri-mesh. There is move a foot to make the tri-mesh have a blend on it, so you can put transparency into it. It's not there at the moment, but it will happen in the near future. Basically, as I said, this in the past was just giving you cross sections. So now you have the ability here to go and create the tri-mesh, which means you can set that tri-mesh directly up to work with your other elements to do your clash detection. So the last two tools in there are just to go and get equalities from a chainage and change from equalities, which then give us the raw to equated chainages along the string. So basically that's all I have in this particular session. Thank you for joining me. I hope that you got something out of it, regardless of whether you're a brand new user or maybe as an experienced user you hung around to see what little carrots we dangled there for you. Remember that we have a great set of training notes on our web page. Remember also that we have a full team of tech support people that are there to answer your questions and help you through any little intricacies that you're unaware of. So thank you for your time, and remember that we have lots of different modules there to do all the different types of modeling and surveying that you may need, and 12D is a great tool. Thank you.